Now we're going to look at a really popular theorem, very useful theorem for right triangles called the Pythagorean theorem. Again, it only really works for right triangles. Right triangles, remember, are triangles that have one right angle. It says basically that in any right triangle with legs that are length A and B, legs are the two sides that are adjacent to the right angle. And hypotenuse C. Hypotenuse is the side opposite the right angle. So the hypotenuse is always the largest one. An interesting thing about triangles, side note, the side opposite the longest or largest angle will be the longest side. I think I said that right. Side opposite the largest angle is the longest side. And then the side opposite the shortest angle will be the shortest side. But anyway, that was a side note. Back to my statement here. Oh my goodness. In any right triangle with legs A and B and hypotenuse C, this relationship right here, A squared plus B squared equals C squared, is true. That relationship allows you to find any side of the triangle given two of the other sides, and it doesn't matter which two. This can be proven. There are many ways to prove the Pythagorean theorem. My favorite, and the one that I always remember, has to do with areas of triangles and squares. If you build a square, or draw a square, whose side length is A plus B, and of course, because it's a square, all the side lengths are A plus B, right? All four of them. And let's cut the side length at A units in, right? So A units in, you cut it, and then you got B units, the rest of it. Then A, cut it, B, and so forth. Then you can connect those segments, or those divisions by line segments, and we'll call those sides C. All right, so what you get is a square in the inside whose side length is C, and a square on the outside whose side length is A plus B. And you can look at the relationship between them, and the triangles here are all right triangles, and they're all similar triangles. In fact, they're congruent triangles because the angles are the same and the sides, corresponding sides, are the same. And the way that we can actually determine this formula based upon this diagram by equating areas. You basically say the area of the big square is equal to the area of the small square plus the areas of the four triangles. And so once we know the areas, the area formulas for each of those shapes, you can add them up and set them equal to the area of the big one. And then just basically do a bunch of algebra on those variables A, B, and C and whittle it down to this equation. Now I won't go through all the details of that. It's kind of beyond what we've done in this course so far. However, it is kind of a basic algebra derivation or proof using that information. We also haven't done areas yet, and so I can't just assume we know how to come up with that. But anyway, we will in later sections. Okay, so anyway, that's how it's derived, just an overview, not the details. But this formula is very useful. Again, we can find the third side of any right triangle if given two of the other sides. So here's an example where I have a right triangle. I have the two legs, which again are the sides adjacent to the right angle, or the two sides that essentially make up the right angle. And if I square those two sides and add them together, I'll get the square of the other side, and all I need to do, or the hypotenuse, and all I need to do is take the square root at that point to solve for C. So we start with I would label these A and B, probably, doesn't matter, it's arbitrary. The A and the B are arbitrary because around the plus sign you can switch those. It doesn't really matter which one's which. The C is important. C has to be the hypotenuse. Okay, that one we don't have a choice, but the legs are arbitrary. So anyway, I start with my formula. A squared plus B squared is equal to C squared. and then we plug stuff in and solve the equation, right? So this is 12 squared plus 16 squared is equal to c squared. All right, now I may need a calculator, I may not. That's 12 squared is 144. 16 squared is escaping me at the moment. 256. Right, so this is 144 plus 256 equals c squared. 144 and 256 is what, 100 or 400? 400, right? 44 and 56 is 100. Plus 100 is 2, plus 2 more is 4. So it's 400 is equal to c squared. And so I got to take the square root of the 400 to figure out what c by itself must be equal to. And of course, the square root of 400 is 20. Right? So c is equal to 20 feet. So it's a 20-foot hypotenuse on that triangle. Okay. In a similar way, we can find some solutions to applications. Here I have a ladder, kind of. This is very rough sketch. A ladder leaning against the house. I have the base of the ladder at 5 feet away from the house, and the length of the ladder is 13 feet. And the question is, how high does it reach on the house? How high can you climb up on that ladder, okay, off the ground? And so it's not going to be necessarily the 13. You would be 13 feet high if that ladder was perpendicular to the ground, straight up. But it's not, it's leaning. And so the top of that ladder is going to come down a ways when it leans out, when you pull the bottom out from the wall. So 5 foot out from the wall. So let's set that up. Now what's interesting about this one is I know the hypotenuse. So this is like our C value, and this would be, I don't know, like our B. It doesn't matter, A and B again. And this could be our A, the H. I mean, wherever you want to plug that. The H could be A or B. And the 5 could be A or B. So let's do it this way. Let's say A squared plus B squared equals C squared. Well, H is kind of like our A. 5 is our B. And 13 is our C. Right, so H squared plus 5 squared equals 13 squared. And then we just evaluate those squares. So H squared plus 25 equals 169. 13 squared is 169. You subtract off the 25 from both sides. H squared is going to be, that's 144. Which means that H is the square root of 144, which is equal to 12. Right? H is square root of 144. If you don't know these square roots, you can always punch them in on your calculator. Your calculator has a square root button. Mine is right above the x squared. It's the second feature of the x squared. So you hit second and then the x squared. It'll pop a little square root up there. And if you don't know the square root of 144, you can always pop it in there and get a 12. Okay. So your calculator can do that if you don't know those. But I assume you probably know a good chunk of these anyway. So the height of the ladder when it hits a house is up there at 12 feet high. So it doesn't come down very far. If you move the base 5 feet out, the top drops 1 foot. Okay, but it is not the full 13 feet. Anyway, the Pythagorean theorem can really be useful. It's a super applicable theorem that we see show up time and time again. This is just a very crude example of how it can be useful, but you can solve, like I showed here, you can solve for the hypotenuse by, if you know the legs and add their squares together. You can also solve for one of the legs if you know the hypotenuse and the other leg, and then subtract the leg off. So square them and subtract the leg off, you can get the square of the other leg. Okay, so a little bit of arithmetic, but super useful theorem.